Hello everyone. In this video, we are going to create a simple neural network model using TensorFlow and Keras. This model can also be considered as the hello world of deep learning. When we think of creating a simple hello world program in any programming languages like C or C++, so there are certain steps involved in it. The first step is to create the code, then we need to compile it, run it, and then verify. Similar to that, in the neural network also, there are certain steps. The first step is to provide labeled dataset. That is to provide the model with input data and corresponding labels or expected results using which the model will train itself. The next step is to define the model. A model is generally defined in the form of layers. So a layer is the basic building block of a neural network. It extracts a representation from the data fed into it. A series of connected layers results in a meaningful representation of a neural network. So here you can see that the layers are defined in a sequential manner, and this sequential defines a sequence of layers in the neural network. So here we are just using a single layer, which is the dense layer, and the parameters passed to the dense layer are the units and the input shape. The units are the number of neurons which we are going to use in our model. So in our case, we are just using only a single neuron. The input shape means the data set which we are providing to the network, whether it's a 1D array, a 2D array, or just a single value. The next step is to compile the model. Now generally when we compile our code in C or C++, so generally everything is handled using the compiler, and we need not to care about what the compiler is doing. But in case of deep learning model, this particular step is very important, because here we need to choose certain parameters like what particular optimizer we are going to use, which particular loss function we are going to use, and so on. So here we can see that the optimizer is used as SGD or stochastic gradient descent, and the loss is used as mean squared error. Loss function means an algorithm for measuring how far the model's output are from the desired output. The goal of training is to measure the loss. It means we can say that the loss is the difference between the actual output and the expected output. Now, optimizer is an algorithm for adjusting the inner parameters of the model in order to minimize the loss. It means the loss function calculates the loss or the difference between expected and actual output, and then this optimizer algorithm adjusts the inner parameters to reduce the loss. The third parameter is the matrix. It is used to monitor the training and testing steps. Generally, in most of the models, accuracy is used as a matrix. The next step is to train the model. To train the model, fit method is used, and the parameters passed are the xtrain, ytrain, and the epoch values. Xtrain is the input dataset provided, ytrain is the corresponding labels, epochs are the number of iterations for which labeled dataset is passed to the neural network. And finally, we need to test the trained model accuracy, and this predict method is used for that. Now let's create the same model in Google Colab and see how it works. Now we are in the Google Colab, and the first step is to import the required packages. So here we have imported NumPy, TensorFlow, and then here we are checking the TensorFlow version. Since version 2.0 is the latest version which TensorFlow is currently providing, so we are going to use the latest version. Let's run it. So here you can see that version 2.0.0 is used. The next step is to provide labeled data. In supervised learning, dataset is provided as both inputs and their corresponding outputs. So in the below data, the inputs are the xtrain values and the outputs are the ytrain values. And if we see the relationship between x and y, so we can see that it can be deduced as y is equal to 2x plus 10. This data has to be converted into an array format with floating point values, and this is done by using a NumPy library. In our normal programming, like in C or C++ or Java, we need to define this equation y is equal to 2x plus 10 in our code, and then only our code will be able to calculate the value of y for any given x. But in case of deep learning, we need not to provide any equation, because the model itself will find the correlation between x and y and derive the formula of its own. So let's run it. We have printed the shape of x10 values and it is showing 11, which means it's just a 1D array with 11 elements. Next step is to define the model. In defining the model, there are certain steps which need to be considered. That is, how many layers we are going to use, how many neurons should be present in each layer, what will be the shape of our input data. So here we can see that we have defined a single dense layer with one neuron and the input shape is also 1. Let's print the model summary. Now here the interesting thing is we have just passed a single neuron, so that's why the shape is 1. But it is showing us trainable parameters are 2. Now why there are 2 parameters? That is because for every neuron we need to train 2 variables. One is the weight and the other is the bias. We will discuss these weights and biases everything in detail in our later videos. Now let's try to get the random weights out of it. Here you can see that both the weight as well as the bias is assigned as -1.55, and you can see from here slash bias, it means this is the bias value and this is the weight value. Now the next step is to compile the model. Now as mentioned, we have compiled our model using SGD and mean squared error as loss. Now the next step is to train the neural network. That is, we need to adjust the weights and biases to reduce the loss as much as possible. Here you can see that with each epoch completion, the loss is reducing. We need to keep an eye on the loss because the loss should be decreasing with every epoch cycle. When the loss reaches to a very small value and stops decreasing further, then it means that the model is not going to train any further, and it's better to use that much epochs only. This technique is also known as early stopping. This is because otherwise the loss may start increasing again as the model will think that it still needs to train and will try to find another global minimum. Training the model works by using the labeled dataset and try to apply its own formula to calculate the output and keeps on improving the result, thereby reducing the loss. For example, let's say in the first iteration, it creates a relationship that y is equal to 2x plus 1. Then it calculates the loss. Then the optimizer optimizes the values of the weights and biases and created a new equation called y is equal to 2x plus 5. In this way, it keeps on increasing or decreasing the weights and biases and trying to minimize the loss. So after multiple iterations, the model will be able to predict that y is equal to 2x plus 10. So here you can see after 500 epochs, the loss is reduced to 0.0808. Now it's time to test the model. Here we can see that the value is 70.60 when we pass the value of 30. So as per the equation, it should be just exactly 70. But in this case, there is an error. So why there is an error? This is because we have fed our model with a very little data, which is just 11 values. If we will feed our model with more values, our prediction result will also be increased. Now let's get the calculated weights. Now here we can see that the new calculated weight is 2.02 and the new bias is 9.8. Now using the equation y is equal to wx plus b, where w is the weight and b is the bias, we can calculate the result, and it's the same result which we get. You can get this Google Colab file from my GitHub repository mentioned in the comment section. In the next video, we will walk through the TensorFlow website and see how we will get the maximum out of it. As an exercise, you can take the temperature values in degrees Celsius as an input and then convert these degrees Celsius value into Fahrenheit using the similar algorithm. That's all for this video. If you have any queries or concern, you can mention in the comment section. Thank you so much. Bye bye.